Hi, this is Javin, a production chemical engineer, proud to present vacuum distillation with you. Now, vacuum distillation is a distillation performed under reduced pressure which allow the purification of compound not readily distilled at ambient pressure or simply to save time, energy. This technique separates compound not readily distilled at ambient pressure or simply to save time, energy. This technique separates compound based on differences in their boiling point. This technique is used when boiling point of desired compound is difficult to achieve or will cause compound to decompose. Reduced pressure decreases the boiling point of compound. The reduction in boiling point can calculated using temperature, pressure, nomograph using Clapeyron relation. Now some of the questions arises in our mind. What is atmospheric and vacuum distillations? Atmospheric distillation is a technique used to separate component in crude oil that is performed under atmospheric pressure. Vacuum distillation is a technique used to separate components by mixture at reduced pressure. Now, by using vacuum is often preferable. Why it is so? The faster processing time, effective distillation while keeping the process under maximum temperature of the distillation unit, heater, and effective processing higher boiling point solvent without igniting them, causing thermal breakdown. Vacuum is preferable. Now, why oil is distilled? The most important questions. The modern separation involves piping crude oil through hot furnaces. The resulting liquid and vapor are discharged in the distillation unit. Refinery have atmospheric distillation unit, while more complex refinery have vacuum distillation unit. What is advantage the vacuum distillation? The primary advantage the vacuum distillation is that it allows the distilled heavier material at lower temperature than those that would require atmospheric pressure. Those avoid thermal cracking of the component. Now, while laboratory scale applications are useful in vacuum distillation, the compound with boiling point lower than 150 degrees centigrade typically are distilled ambient pressure. For sample with high boiling point, salt bath distillation apparatus is commonly employed. This technique is applied illustrated in organic synthesis. Industrial scale distillation applications. Industrial scale vacuum distillation have several advantages. Close boiling mixture may require many equilibrium stages to separate the key component. One tool to reduce the number the stages needed is to utilize vacuum distillation. Vacuum distillation column typically used in oil refinery have diameter ranging 14 meter, height ranging up to 50 meter, and feed rate ranging up to 25,400 cubic meter per day, means 160,000 barrels per day. Vacuum distillation can improve a separation by prevention of product degradation of polymer formation because of reduced pressure leading to lower tower bottom temperature, reduction in product degradation or polymer formation because of reduced mean residence time, especially in column using packing. Their tray increases capacity, yield and purity. The another advantage the vacuum distillation is the reduced capital cost at the expenses of slight more operating costs. Utilizing vacuum distillation can reduce the height and diameter and those capacity cost of distillation column. The vacuum distillation in petroleum refining. The petroleum crude oil is a complex mixture, the hundred of different hydrocarbon compounds, generally having 3 to 60 carbon atoms per molecule. Although there may be small amount hydrocarbon outside ranges, they require crude oil being with distilled the incoming crude oil. The so-called atmospheric distillation column, operating pressure slight above atmospheric pressure. Vacuum distillation can also refer lower temperature distillation. In distilled, the crude oil important not subject the crude oil to temperature about 370 to 380 degrees centigrade because high molecular weight component in the crude oil with undergo thermal cracking and from petroleum coke, the temperature above the formation of coke would result in plugging the tubing furnace that heat the feed stream to the crude oil distillation column. Plugging would also occur piping from furnace to the distillation column as well as in column itself. The constraint imposed by limiting the column inlet crude oil a temperature less than 370 to 380 degrees centigrade yield residue oil from the bottom of atmospheric distillation column consisting the entirely hydrocarbon that boil above 370 to 380 degrees centigrade. The further distilled residue oil from atmospheric distillation column, the distillation must be performed absolute pressure as low as 10 to 40 mmHg torr, about 5% atmospheric pressure, so as the limit operating temperature less than 370 to 380 degrees centigrade. The 10 to 40 mmHg absolute pressure in vacuum distillation column increases volume of vapor form per volume of liquid distilled. The relief is that such column have very large diameter. The distillation column such have diameter 15 meter or more, height ranging 50 meter and feed rate ranging up about 25,400 cubic meter per day. The vacuum distillation column internal must provide good vapor liquid contacting while at the same time maintain a very low pressure increases from top of the column, top of the bottom. Therefore, the vacuum column uses distillation tray only where products are withdrawn from side of the column. Most of the column use packing material for vapor liquid contacting because such has a lower pressure drop than the distillation tray. The packing material can be either sheet metal or random dump packing such as rusting ring. The absolute pressure 10 to 140 mmHg vacuum column is most often achieved by using multiple stages steam jet ejector. Now, its application in large scale water purification. Vacuum distillation often use large industrial plant as an efficient way to remove salt from ocean water in order to produce fresh water. This is known as desalination. The ocean water is placed under a vacuum to lower boiling point and has a heat source applied, allowed it fresh water to boil attend the condense. The condensing the water vapor prevent the water vapor from filling the vacuum chamber, allow the effect to run continuous without loss of vacuum pressure. The heat from condensation of water vapor is removed. Heat sink which uses incoming ocean water as coolant and those preheat the feed of ocean water. The smoke from distillation do not use condenser but instead they compress the vapor mechanically with a pump that acts as a heat pump concentrating the heat from vapor and allow that for heat to be returned and reused by incoming the treated water source. There are several forms the vacuum distillation of water, most common being multi-effect distillation, vapor compression, desalination and multi-stage flash distillations. Now, molecular distillation is a vacuum distillation below pressure the 0.01 torr. The 0.01 torr is the one order the magnitude above high vacuum where fluid are the free molecule, flow regime, flow path molecule is comparable to the size of equipment. The gaseous phase no longer exert the significant pressure on the substance to the evaporate and consequently the rate of evaporation no longer depend on pressure. That is because continuous assumption of the fluid dynamic no longer apply. Mass transport is governed by molecule, a dynamic rather than the fluid dynamic. Those salt path between hot surface and cold surface is necessary, typically suspending a hot plate covered with film of feed next to a cold plate with line. The site in between the molecule distillation is used in industry for purification of oil. The pros and cons of the vacuum distillation. The vacuum distillation performed under extremely lower pressure This is ladder. The causes they would normally result the boiling point being way the below the operating temperature. So vacuum distillation is generally performed the reduced pressure. The most commonly advantage is that the operating temperature can be reduced, thus allow distillation material that decompose or that the polymerize. Higher temperature vacuum distillation is sometimes indicate the material that react with air and higher temperature through they can advantage to use a non-reactive gas mixture instead. However, most widely used industrial application, the vacuum distillation is where each signal stage the distillation provide the pure product than the distillation at higher temperature. This is possible because relative volatility, the ratio of vapor pressure of the vapor is generally higher at lower temperature. The principal disadvantage, the equipment is more complicated to build and thus the low vapor pressure tend to limit the flow rate of the vapor and hence reduce the capacity for equipment any given size. Now, what is difference between tower, atmospheric distillation and vacuum distillation in oil refinery? The main difference is of the pressure. Now how? Atmospheric has pressure around 1 to 3 atmosphere and pressure of the vacuum distillation tower below 1 atmosphere. So separation become easy in case vacuum distillation lower because reduction the boiling point lowering the pressure. The bottom product from the atmospheric distillation tower is taken in vacuum distillation tower for further refining. Therefore, difference dimension also diameter the vacuum distillation tower is higher than the atmospheric distillation tower. The most important reason for the diameter the vacuum distillation tower being higher the atmospheric column is to minimize the pressure drop across the column. To maintain the vacuum pressure profile across the column is expensive affair, so lower the pressure drop across the column better. Thus also the reason why oil refining industry mostly vacuum distillation column employ packing instead of tray. Okay guys, this is up to vacuum distillation column in brief manner. I hope you get sufficient knowledge. Do take good care of yourself and wishes you a happy Sunday ahead.